Okay, this is a basic description of what's going on in 6.2. All right, so here's a rectangle, and it goes from -1 past 0 up to 1. So that's a distance of 2. And if it goes up to height 1, then the area of this, okay, let's just talk about the area if I color it in. The area is, well, it's 2 by 1, so it'd be 2. Percent colored in, so that percent is the percent that's colored in. Well, 100% of it is colored in. What's the probability that if I throw a dart, it has to land in the blue area, or it has to land in the rectangle, rather. What's the percent that it lands in the blue area? If it's definitely going to land in the rectangle, can't land out here for some reason. If it's got to land somewhere in the rectangle, it's 100% chance, or probability 1, that it's going to land on a blue part. Okay, so how about if, instead of that being 1 high, let's call it 1/2 high. Okay, so now let's re-answer all these questions. All right, the area that's colored in, well, it's 2 by 1/2, 2 times 1/2. The area is 1. Percent colored in is 100%. And the probability that I land in a part that's colored in, if I have to throw it into that rectangle, that's 1. It's definitely going to land on a blue part. Okay, this rectangle is better than the last rectangle because basically all the answers are the same. Area is 1, probability is 1. You switch that into a percent, it's 100%. That's all the same question. So whenever you're reading any problem, it'll say, what's the area of this? What's the chance of that? What's the probability of this? It's all the same question, and it's all the same answer, and there's only one procedure. So that was really why I was going through that. But before we move on, let's try another question. Okay, so all of a sudden, I have that much colored in. Okay, it's 1 by 1/2. The area is 1/2. 50% of it is colored in. And the probability, it's going to definitely land in the rectangle. So probability lands in the blue part, well, that would be 1/2. Okay, so it is. It's definitely the same question. And this is really easy because it's geometry, and I know how to do rectangles. That's like, length times width. I could do that. But what if all of a sudden I change to a bell curve? There it is. There's a bell curve. Okay, and I can't figure out the area of bell curves. We didn't do bell curves in geometry. And you really can't do bell curves in geometry. It would be calculus. So you'll just have to take my word for it. The area under that curve is exactly 1. So if I colored in the whole thing, it'd be like that rectangle I just erased. Okay, the area is 1. Okay, the percent that's colored in is definitely 100%. Because I know they're the same question. As long as I get the area 1, I can make the other. I got to throw a dart. It's definitely going to land in the bell. What's the chance it lands in a blue part? That would also be 1. Once you get the area 1, the rest of the questions are just basically the same question. All right, now how about if this is like right down the center, right where the mean is, and this is colored in over here, not colored in over there. Okay, now all of a sudden I want to go, oh, what's the area of the part that's colored in? Well, if the area of the whole thing was 1, the area must be 1/2. Still don't know any calculus, but it must be. If the area of the entire thing is 1, the area of that must be 1/2. Percent colored in would be 50%, and chance of landing in a blue part is 1/2. Okay, so it's still the same question 3 times over. Now, how about if I put my line about here? Let's say that's at the point -1. This was 0. Okay. And now I'm trying to figure out what's the area of that. Well, sort of, almost, kind of looks like a triangle, but not really. And I don't even know what base and height to use, and it goes out to infinity anyway. And I just don't even know. And you told me you got this stuff from calculus. Okay, the answer is there's no way to know this. Not with geometry, not with anything I've done so far. And we're not going to do calculus. So what they did back in the day is they created a table. One person who did know calculus worked it all out and figured out what the area of that is. Okay. And then the rest of us just believed them. Well, it's okay, except I'm going to be carrying around a chart for the rest of my life. So it's actually in the calculator. All right, we'll just go over it in the next video, but there's this great and wise calculator. Please tell me, if I start at negative infinity and end up over here at -1, what is the area of that? And the calculator will tell me, and it doesn't matter if the problem actually asked me for the probability instead. Since it's the same question, I'll just keep asking my calculator, oh, between there and there, tell me what that is. Okay, and that's what's going on in this chapter, is that we've got a calculator button that will tell us various little areas of this bell. And that's the way we're going to find out the area. So we don't have to look it up on a table, and we certainly don't have to do calculus.